to find slopes along polar graphs, you are still trying to find dy dx. It's still the same derivative that's going to give you the slope, still dy dx. Back in chapter 4, there's a formula for figuring out slopes of parametric graphs, parametric curves, as ratios. They were written back there as dy dt over dx dt. Well, the parameter is theta here, so I'm going to write dy d theta over dx d theta. All right, so could this be simplified? Yeah, we can use these equations. Though it's not going to look simpler when I simplify it. It'll just be written in terms of f and its derivative f prime. So you might say it's, even though it's not going to look simpler, it might be better. Dy d theta is the derivative of this with respect to theta. We've got the product of two things. We need the product rule. Left d right plus right d left. Left is f of theta. D right, the derivative of sine theta with respect to theta is cos theta. That's left, d right meaning derivative of the right. Plus right, sine theta, d left, the derivative of the left is f prime theta. That's right, d left. Do the same kind of thing on the bottom, except with this equation instead. Left d right is f of theta times the derivative of cosine theta, which is negative sine theta. So I'm going to get a negative sign in here, f of theta sine theta. That's left d right plus right cos theta d left is f prime theta. It's going to be a little bit more convenient for us to, well, at least initially, write this in Leibniz notation and use the fact that r is f of theta. So dr d theta is f prime of theta. Another way to write this is as r cos theta. I'll dispense with the extra parentheses now too. R cos theta plus dr d theta sine theta over negative r sine theta plus dr d theta cos theta. Or if we're feeling really lazy, instead of writing dr d theta, write r prime. R cos theta plus r prime sine theta over negative r sine theta plus r prime cos theta. Realize when I write that, r prime means dr d theta. It's a derivative of r with respect to theta. And I am kind of abusing notation in writing that. R prime is effectively the same as f prime, though r is a variable and f is a function name. But you know, you've been sloppy with this kind of thing before. We can deal with it. Okay. So for our example, how could this work out? We should find dr d theta, f prime of theta. If we do that, we will get negative 4 sine theta. And therefore, if we wanted the slope at a certain value of theta, we could use this formula. Maybe in this form. What value of theta would I like to find the slope at? How about at theta equals pi over 2? Visually, it looks like the slope might be close to 1. Is that right? Let's see. Let's find dy dx. Evaluated at the point r theta equals, when theta is pi over 2, r is 2 comma pi over 2 is where I need to evaluate this. Probably it's easiest to think about, well, I guess you might say it's easiest to think about using this one. If I use this one, to make sure I don't make a mistake. Well, okay, or no, maybe it's easiest to use this one. Make sure I don't make a mistake. R is 2. Theta is pi over 2. dr d theta is a little trickier though. That's the derivative here, -4 sine theta, evaluated at theta is pi over 2. -4 sine pi over 2 is the value of dr d theta when theta is pi over 2 times sine of pi over 2 divided by, on the bottom we'd have -r is -2 sine pi over 2. Hopefully we're not dividing by 0 here. dr d theta is -4 sine pi over 2. That gets multiplied by cosine of pi over 2. I'm hoping for an answer close to 1 here. Is it? Pi over 2 is 90 degrees. Cosine of that is 0. Sine of that is 1. The cosines get replaced with 0. The sines get replaced with 1. Plus sign here, plus -4 times 1 times 0. Looks like the answer is closer to 2 instead of 1. Yeah. -4 over -2, which is +2. So my picture by hand, I wasn't accurate enough to estimate the slope as close as I want. It's actually a bit steeper there than I drew it. Slope is 2. Can we see that if Mathematica has a more accurate picture? Probably. Yeah. Focus on this point here. Yeah, the slope is steeper than I drew it by hand. So drawing it by hand can get you into trouble if you don't do it very accurately.